In this video, we will know how to calculate the energy or power of a triangular function. The function is given using that graph like from 0 to 2 and x of t. So we need to determine the energy of the signal. We know that the triangular function is written using this equation: x of t is equals to a multiplied by 1 minus t amplitude divided by capital T. So if that is the graph, so we can interpret that graph using this mathematical equations like x of t is equals to t from 0 to 1, where it is equals to 2 minus t from 1 to 2. How? We will see that this function is simply a ramp function. So that is why we can represent x of t is equals to t from 0 to 1. While that signal, we can say that okay, it is a time scale. For this signal, we can say that it is a shifted version of a ramp signal. So the shift is t minus 2. So while it is from the graph, we see that it is on the other side, it is a reflection. So we will do the reflection of that signal, and we can see that the signal is now looks like the same as given by the graph, but we multiplied that with the minus t minus, but we multiplied t minus 2 with the minus sign. So like here, we will calculate the energy of that graph, because from the graph we can say that it is a finite duration. So we will use the energy formula for the finite duration signal. So E is equals to integral from minus t to t x square t, which is equals to integral from 0 to 1. So that was ramp function, so t square, plus integral from 1 to 2, that is 2 minus t whole square. If you simplify these two integral, you will end up with these two equations. Like the integral of t square is t cube by 3, the limits from 0 to 1, plus, because this is whole square, you can open that square using this formula: 2 square 4 t square minus 2 times 2t, so which is equals to 4t. So if you simplify, or if you take the integral of this equation, you will end up of this equation like 4t plus t cube by 3 minus 2t square with the limits from 1 to 2. And after simplification, we will get the energy of the given signal, which is equals to 2 by 3 joules. There is another example, like you need to determine the energy of the given signal. So the graph of the signal is given. The graph of signal is given. Using that graph, you can write the mathematical equation, and from the graph you can say that it is a finite duration signal. So that is why you can use the energy equation for the finite duration signals. So from the graph you can say that from minus 2 to minus 1, it is simple a ramp function. And similarly, so you can say that from minus 2 to minus 1, it is a ramp function, but you can say that it is a shifted version, and the shift is at 2. So that is why t plus 2. And on the other side, you can say that it is a shifted version as well as the reflection that we have already done. So you can represent that reflection using minus t minus 2, minus of t. So using this equation, and you can represent this side by using the reflected ramp function, reflected and shifted on the right side. So you just need to insert these equation in the energy equation, and you can write from minus 2 to minus 1, the shifted ramp function was t plus 2, and then from minus 1 to 1, the answer was 1, and then from 1 to 2, it was also shifted and reflected ramp function. So you just need to simplify these equations using a simple algebraic functions, and then you will end up with the integral of all those equations with the given limits. And if you insert all those limits, you will end up with the energy which is equals to 8 by 3 joules. Another signal which is a ramp signal, and you can check the energy and power of the ramp signal. Mathematically, you can write the ramp function using this equation: r of t is equals to t when t is bigger than 0, and 0 when t is less than 0. And you know from this graph that the signal is of infinite duration, so you can use the equation of energy for the infinite duration, and then you will insert the signal x square of t. So xt, which is a ramp signal, r square of t, so which is a t, so the t square, and you know that the integral of t square is t cube by 3. So if you insert upper limit and lower limit and use the limit t tends to infinity, you can see that the energy of the signal is infinite. Similarly, you can calculate the power using the power formula, as the signal is of infinite duration, so you need to use the equation for power for the infinite duration signal. So again you can perform the simplification, and you will see that the power of the signal is also infinite signal. So this shows that this signal is not a power signal, neither a energy signal. So there is another type of signal. You can say that the real signal and the imaginary signal. A signal is said to be real if it satisfies the following condition, like x of t is equals to x star of t. Similarly, a signal is said to be an imaginary signal if it satisfies the following conditions, like x of t is equals to minus x star of t. For a real signal, imaginary part must be 0. You need to keep this in note. And similarly, for an imaginary signal, the real part must be 0.